For the last part of Notes 18, we're going to look at how we can have SAS calculate the sample correlation or the correlation coefficient for us, and then we will see how we can do hypothesis tests related to correlations as well. So here's kind of the general code. We're going to use something called proccorr, C-O-R-R. We'll put data equals the name of our data set. We'll have a line that starts with var. In the past, we've put quantitative variables on lines with that name. We will put both of our quantitative variables on this line, and then we'll use run at the end. So I'll show you an example of this for the Challenger dataset in just a bit. But first, let's take a look at what the output looks like and how we can answer questions related to it using SAS. All right. So when I run the code above, just sort of a generic version of it, this is the kind of output that I will see. So it'll tell me that these are the Pearson correlation coefficients. I'll have my x variable and my y variable, x variable and y variable, and then I've got sort of a grid here giving me some numbers that I need to know what I can do with these. All right. In each of these rows, the top number is going to be our sample correlation. The bottom number is going to be a p-value. So if I'm looking for the sample correlation between x and y, I can go x variable, y variable, so that's this section here, and this top number, the 0.63801, that is my r, or my sample correlation between my x variable and my y variable. If I wanted to know the correlation between my x variable and itself, it's going to be 1. There's a perfect relationship between those. If I know x, I can tell you x, right? Whereas if I know x, I can do a decent job telling you what y is because there's a sort of moderate to strong relationship between those. So if this bottom number is a p-value, we should figure out what kind of test it's related to and how we could carry out one of those tests. So the p-value will test this hypothesis. Our null model will say that the population correlation is 0, and our alternative model will say that the population correlation is not 0. So remember that this 0.63801, that is a sample correlation. It is calculated based on my data or my sample. But what I really want to know is, do these variables have a relationship for my entire population? I can write this in symbols as well. The symbol for the population correlation is this sort of, I don't know, weird looking like lowercase p. It's actually the Greek letter rho. So lowercase r is our sample correlation. This Greek letter rho is our population correlation. So you can write these hypotheses either way. Either one is fine. If you want to just stick with writing them out in words, that might be a little bit easier for you. So if I get this p-value of 0.0001, we've done enough hypothesis tests at this point that hopefully you're already sort of jumping ahead to what kind of conclusions would I reach. And since my p-value is very small, I am going to have sufficient evidence that the population correlation is not 0. So I have sufficient evidence the alternative hypothesis is true because I got a very small p-value. So based on my p-value of 0.0001, there is very strong evidence to conclude that the population correlation between the x and the y variable above is not 0. If you want to see what that looks like for an actual example, we can go back to our Challenger dataset. So here was the code from SAS on demand, and we previously made a scatter plot. Now we're going to use proccorr to figure out what the actual sample correlation is. So I'm going to put data equals Challenger because that's my dataset name. And then the only two variables I have, they're both quantitative. So I'm going to put both of them on this var line. I'm going to put temp and index. And then I've already read in the data, so I can just highlight this part here and hit run. And this is the part that was in the notes. All right, so this is the part we're focusing on. And if you look at the intersection between temp and index, I've got this little section right here. And remember, this top number is the sample correlation. So the correlation between the temperature and the damage index is negative, right around negative 0.8. And that fits sort of with what we saw before, that there was a negative direction for our scatter plot. And we weren't quite sure if it was moderate or whatever. It looks like the relationship's actually fairly strong. But again, it can be hard to tell that if you're just looking at a few data points. So this was based on only 12 values. Our sample size was 12. We may want to know, well, does this mean that the population correlation is also not equal to 0? And in fact, the p-value for this test is only 0.0028, which would tell me that I have pretty strong evidence that the population correlation between O-ring damage index and temperature at launch is not 0. So there is some sort of linear relationship between the temperature at launch and the damage index. All right, so that will wrap up Notes 18. In the notes that will follow this, we will start to talk about how we can actually calculate equations for the line that you might draw on your graph, how we can use those to make predictions, and to really explain the relationship between these variables a little more thoroughly for someone who might be interested.